Hello everyone and welcome to today's Explainer. Today we're going to talk about something really exciting, new computer parts. You see, artificial intelligence, or AI, is getting super smart. But here's the catch. AI needs really powerful computers to work. Our old computers, well, they're just way too slow. So let's jump right in and see exactly why we need to change them.
Okay, here's our map for the Explainer today. First, the AI computer problem. Second, building taller memory chips. Third, new brains for AI. Fourth, AI inside your laptop. And finally, materials for hot machines.
All right, let's start with part one, the AI computer problem.
So why do our computers actually need new parts? Well, the answer is pretty simple. AI uses a whole lot of power. Think about it. AI has to solve millions of math problems all at once. Our older computers just use way too much electricity to do this. They literally cannot keep up with the demand.
Here's the main issue. Old computers separate the memory from the brain. The brain is the main processor. Because they are separated, the data has to travel a really long way between them. It just moves back and forth, over and over again. And you know what? This long trip wastes a ton of energy. Plus, it slows down the work. It's kind of like the data gets stuck in a huge traffic jam.
Moving right along to part two, building taller memory chips.
Now you might be wondering, how can we make more memory? AI needs a huge amount of it, that's for sure. But those old memory chips, they've completely hit a wall. We just can't build them the old way anymore. It's become way too difficult.
To understand why, think about this. Old chips save data by digging deep holes. Imagine a hole in the ground that goes down as deep as a 100-story building. That is incredibly deep. Trying to dig holes like that on a tiny little computer chip is just too hard now. The walls are so thin they can actually break. So we really needed a fresh idea.
So here is the big fix. Engineers changed the whole shape. They do it in 2 steps now. Step 1, they just stop digging those deep holes. Step 2, they build the memory chips up instead. They look like tiny, tall office buildings. We call this 3D memory. This brilliant idea makes much more room for data, and the chip doesn't even have to get any wider.
Let's move on to part 3, new brains for AI.
Okay, so what exactly is a TPU? You probably know about a CPU, right? Well, now we have these very special brains made just for AI. The TPU is a great example of this. It's a special chip made by Google.
Let's compare the two. A CPU is kind of like a boss in a busy office. The boss has to handle a lot of different jobs all day. But a TPU, it's more like a worker on a factory assembly line. That worker does just one simple job, but they do it incredibly fast. The TPU only does math for AI. That's its only job, which makes it absolutely perfect for the task.
We also have this amazing new chip called the Lenzo CGLA. Let's put this into perspective. If a normal chip uses 100% power, the Lenzo chip uses only 10%. That saves a massive amount of energy. How do they do it? They simply put the memory very close to the brain. Because they are close, the data doesn't have to travel far at all.
Now for part 4, AI inside your laptop.
So, how can our everyday laptops run AI? Usually, big AI programs have to live in giant, noisy server rooms. But right now, that big AI is actually moving into small computers. We want AI sitting on our home desks. We want to carry it around in our backpacks.
A big part of this is the new NVIDIA RTX Spark chip. It uses something called unified memory. This simply means there is one big pool of memory, and the entire computer shares it. We're talking about a shared pool of up to 128 gigabytes. That is a massive amount of space for a laptop. And because the data stays in just one place, the computer runs super smoothly.
Because of this, your computer is really changing. It's moving from just a simple tool to a true teammate. It's going to become a smart helper that does multi-step tasks for you. Instead of clicking 100 times, you can just ask it to do a job, and it handles the whole thing for you.
These new laptops come with some fantastic features. They are thin and light, so they're easy to carry. They have an all-day battery life. They run AI very, very fast. But maybe most importantly, they have local security. That means your private data stays safely inside your machine. It doesn't get sent out to the internet. You stay safe and secure.
And finally, part 5, materials for hot machines.
Here is a big question. How do we stop the heat? You see, these new AI chips work extremely hard, and all that hard work makes them very, very hot. That high heat can actually break normal computer parts, so we really need new, tough materials to stop this heat from ruining everything. Well, a company named Toray made a brand new material to fix this. Check this out. This material survives heat of over 200 degrees Celsius. That is literally boiling hot. To give you an idea, water boils at 100 degrees Celsius. So this new material is seriously strong.
We use this strong material to protect sensors. Sensors of little parts that feel things, right? For example, they feel vibrations inside big, hot machines. We really need these tough sensors for AI robots and for smart cars. Normal computer parts would just melt under that stress, but thanks to this new material, the sensors stay totally safe.
All right, let's wrap up what we learned today about the future of computing. We saw those tall 3D memory chips. We looked at special new brains, like the TPU. We discovered super smart laptops that use unified memory. And just now, we learned about strong materials to protect hot machines.
So I'm going to leave you with one final thought. Will future computers look exactly like the human brain? Think about it. These new chips are already passing data around just like human nerves do. They are acting more and more like a real, living brain. It's truly an amazing time for technology. Well, thank you so much for joining me for this explainer. See you next time.